One way to see where a car gets its power is to raise the hood. Or you might do this. Not only would you get to see the whole works, you'd also get a good look at me, the engine. My power starts here with my pistons. They're not very big, and they don't move very far up and down, only about 3.5 inches. Also, they never move this slowly. When you're driving out on the highway, they go much faster than this. Actually, each piston goes up and down 80 times per second. Hard to believe, but true. In that little 3.5 inches it travels, the piston starts up from a dead stop at the beginning of each run, reaches a speed equivalent to 50 miles per hour at the halfway point, and then comes to a full stop at the end of the stroke, and does it all again over and over 80 times per second. And that makes my power. I'd like to show you exactly how I do it. Let's begin with a cylinder. This one is closed at one end, you'll notice, like a cannon. Put in a charge of gunpowder, pack it tight, then the ball, ignite it, power. Now change the cannon to a cylinder. Add a piston. That's also a cylinder with one end closed. Also add rings to make it fit snugly and hold pressures, and to keep the cylinder walls clear of excessive oil. Put in an explosive, a mixture of gasoline vapor, the fuel, and air. I compress it, and then use a spark to ignite the mixture. It burns quickly, expands, and pushes the piston down with great force. I drive out the burned gases and start the cycle over again. Intake, compression, power, and exhaust. I work a cycle of 4 strokes of the piston, which makes me a 4-stroke cycle internal combustion engine. Now, to turn the wheels. Each of my pistons has a large pin that links with a connecting rod. Its lower end is connected to the crankshaft. As the piston moves up and down, the connecting rod causes the crankshaft to turn. You can see my power action in the cylinder is straight line motion up and down, or reciprocating. The connecting rod and crankshaft change it to rotary motion, which is what I need to be able to turn the wheels. My designing engineers put a heavy weight called a flywheel on the crankshaft. It's needed to smooth out my power stroke and carry it through the 3 non-power strokes that are part of each cycle. I have 2 valves per cylinder. They are called the overhead type because that's where they are. The intake valve opens to let the fuel and air mixture in as I start the intake stroke. The valve closes for compression and stays closed during the power stroke. The exhaust valve opens about the time the power stroke ends, so that I can drive out the burned gases during the exhaust stroke. At the bottom of the stroke, the cylinder space has a certain volume, the space for the fuel and air mixture. Say it's 56 cubic inches. As the piston rises, it compresses the air and fuel mixture into a very small space, say 7 cubic inches. That means I have a compression ratio of 56:7, or 8:1. The fuel and air mixture comes from my carburetor, which does a very precise mixing job. My fuel pump puts the gasoline into the carburetor bowl. A float shuts off the inflow, preventing overflow. The bowl is connected to a tube with small openings at the tip. As the piston goes down, it causes a stream of air to be drawn in through the air cleaner and down past the tube. drawing a fine spray of gasoline with it. The gasoline droplets quickly vaporize as the mixture of air and fuel goes to the cylinder. The throttle valve is operated by the accelerator pedal and controls the amount of mixture entering the cylinder, and that controls the power I develop. Each cylinder has a spark plug. The low voltage electricity from my battery is increased to high voltage by an electric coil and causes a spark to jump the gap and ignite the mixture. The time when this happens is handled by my distributor. It's turned by a shaft that's geared to the engine so that the electricity is switched to the proper spark plug at just the right moment. But before I can be a practical engine, I need a few more parts. For one, a block. It's usually a large piece of cast iron with a cylinder formed by boring right through the block. Then there's my head, more like a cap, really, fastened on tight enough to keep me from blowing it off when the pressures inside go up. Underneath, a removable pan holds the oil I need for lubrication. I also need some mechanism to open and close my intake and exhaust valves. That's my camshaft. It is geared to my crankshaft by timing gears so that, like the spark, the opening and closing of the valves will come at the right time. The camshaft turns once, while my crankshaft turns twice, because the valves must open and close just once in every 2 revolutions of the crankshaft. The cam system operates the valve train, a lifter, push rod, rocker arm, valve, and spring. With each turn of the shaft, the cam pushes up the lifter and the push rod, raising the rocker arm so that the other end pushes down on the valve, opening it and compressing the spring. When the cam turns away from the lifter, the action reverses, and the spring holds the valve closed tightly. My intake manifold connects the carburetor and the intake valve, and my exhaust manifold conducts the exhaust gases from the cylinder to the muffler and tailpipe. So far, I've shown you just one cylinder. Engines have more. Here's a 4-cylinder engine. The crank's positions permit the cylinders to deliver their power thrusts in succession for a smooth, even flow. There are 6-cylinder engines too, of course. And by combining 2 4-cylinder engines this way, you have a V8. It uses a single crankshaft for the 2 sets of pistons and their connecting rods. Another variation of design is the overhead camshaft arrangement, which eliminates the push rods and rocker arms, but has to have a large chain belt or a gear drive to turn the camshaft. I have a cooling system to keep my various parts from overheating. One of the system's components is a water jacket, really just a space in my block and head through which a coolant flows. It may be water or water with an antifreeze added. Hoses connect the jacket to my radiator, which is made up of a good heat-conducting metal with spaces that allow air to flow through. A water pump and fan, together on one shaft, are driven by a belt, which in turn is driven by a pulley on my crankshaft. The pump circulates the coolant so that it absorbs engine heat, then goes to the radiator where the outside air carries off the heat, cooling the coolant, and the cycle is continuously repeated. The fan helps to keep outside air flowing through the radiator at times when the car is not moving. On cars with automatic transmissions, there is a small, separate section of the radiator that cools the transmission fluid. I have to have a lubrication system too, otherwise friction would quickly burn me right up. The system includes the oil supply in the oil pan, an oil pump, and small pipes and spaces that carry the oil to all of my moving parts. The pump circulates the oil through the main bearings, the areas where the crankshaft rests on special metal supports, then through passages inside the crankshaft, and from them into the connecting rods, which also have oil passages drilled through them. In this way, the oil gets to the piston pins. The cylinder walls are lubricated by oil thrown on them from the lower connecting rods. The circulated oil, which serves to keep me cool and clean, as well as lubricated, drops back into the pan for recirculation by the pump. It seems like I'm a big bundle of systems. Lubrication system, cooling system, valve train, fuel, and ignition system. So what's new? You'll be glad I asked, because I also have pollution control systems. You may have heard about the PCV system. That's positive crankcase ventilation. Here's the inside story on it. The crankcase of any engine, regardless of age, accumulates a certain amount of blow-by gases, which are unburned and partially burned gases that get past the pistons and into the crankcase. For many years, a draft tube was used to draw these gases out into the open air. They made up about 1/5 of all automotive hydrocarbon emissions. The rest of the automotive hydrocarbons came from the exhaust pipe and by evaporation of gasoline from the carburetor and the fuel tank. In a PCV system, a hose with a one-way control valve in it connects one of the valve covers to the intake manifold, and another hose connects the air cleaner to the other valve cover. The crankcase gases are drawn up and into the cylinders where they are burned. Clean air replaces the removed gases. PCV, in use since the early 60s, has essentially eliminated hydrocarbon emissions from the crankcase, except on old, unequipped engines. Another anti-pollution system is CCS, the Controlled Combustion System. It provides a more complete burning of the fuel and air mixture. The hot exhaust manifold is used to heat the under-hood air taken in by the carburetor. This allows the air and fuel mixture to be set leaner, which, combined with the installation of a high-temperature thermostat in the cooling system and a change in the spark timing, reduces the amount of hydrocarbons and carbon monoxide in the exhaust. Another system, called the air injection reactor, is a sort of exhaust afterburner. An air pump, belt driven by the engine, forces a stream of air into the exhaust manifold near each exhaust valve. This extra supply of air causes most of the unburned hydrocarbons to be burned before they reach the tailpipe. The ECS, or evaporation control system, captures fuel vapors from the fuel tank when the engine is not running and stores them in a carbon container until they can be burned in the cylinders when the engine starts again. I've come a long way from the old days of our early cars. I've been improved upon during the years to do a better job for you. And I've changed quite a bit from what I used to look like. My emission control systems have changed me even more, and there are still more advancements in my future. I hear the engineers talking about me, and I'll bet they don't think I'm listening, or that I have something to say to you. It's this. Basically, the way I work to make power is not very complicated, as you've seen, but I do need care. Keep me well lubricated and clean and well adjusted, and I'll do well by you. And thanks for listening.